All right, let's start again. The graph shows the mass of three substances for volumes between 0 and 60. What is the mass of 30 cubic centimeters of each substance? So we're looking for 30 cubic centimeters. So you're reading that down here, and all you're really doing is reading off the graph. So in order, they would be, that's 100. So this one here would be 50. It'd be a little bit easier if I put my numbers on there, wouldn't it? 50. So would you say, I don't know, about 60 or so? Because that mark starts is going to be 75, isn't it?
Yeah.
Maybe even a little higher, maybe 62. Would I mark it wrong if you put 63? Not me, Lane, you know that. No, well, yeah, now you're getting into the wrong area. Yeah. This one here would be, looks like just under 100, let's say 95. And this one here looks like it's right on that line. What line is that? 150, maybe a smidge below. Pretty easy stuff, right? You've all read graphs before. If you had 100 grams of each substance, what would their volumes be? So here you're going the other way, right? 100 grams, so you're going this way. So you would have 20 cubic centimeters, and here you would have, looks like 35. And here you would have about 50. 20, 35, and 50 grams. Yeah, it's a little scrunched in there, eh? 25, what did I say, 30? 30, 20, 35? What are the units of the slope of the graph? How do you find the units? You take the y units and you divide by the x units. So they're going to be, now you don't have this question, do you? Is this the one that I fixed? You have this? Okay, on the old one or the new one? Or both? Okay, good. Okay. Oh yeah, I separated. Grams per cubic centimeter. I think it's D that I added in, right? Okay. Because I wanted you to calculate the slope. So what is the value of the steep slope? Now you didn't do this because you didn't have this question yesterday. So how would we find the, well, the steepest slope would be this one here, right? Can I just do, remember it's rise over run, y2 minus y1 all over x2 minus x1. Can you just go 300 over 60? Which is what? Is it 5? 5 what? Grams per cubic centimeter. Well done, whoever said that. Why is it grams per cubic centimeter? Because that's the unit for the slope, right? Y divided by x. 5 grams per cubic centimeter. Now, can I just do 300 over 60? In this case, yes. How come? Because you can't always do that. That's going to get you into trouble if you always do that. You know why, Lane? No? Matt, you know why? No? Ladies? On the female side of the room? The question was, can you always just take this number and divide by that one? Because this says like y2 minus y1. How come I didn't do any subtraction? I sort of skipped a step. Because the line goes through what point? 0, 0. So what I really did was I went 300 minus 0 and 60 minus 0. But because we all know that that's not going to change the value, we just sort of ignored it, right? But what if the line doesn't go through 0? Can you do that? No. Then you have to do the subtraction. So watch out for that, right? What if I just took two other data points? Like what if I took that data point and that data point and did the proper, would I get the same number? Yes, because the slope of the line is what? Constant or the same. It's 5 everywhere. It's 5 everywhere. Okay, good. I think you got a good handle on that. E, describe the meaning of the slopes of the lines of the graph. How many people have an answer for this? Be brave.
Linear.
They are linear. That's not the answer I was looking for, but you're right, they're linear. Describe the meaning. In other words, what property are they of the system? What do they mean? In the examples, they were what? Do you remember? What was that 0.74 seconds? Reaction time. So the answer to the question there was reaction time, because it was distance divided by time, right? Or sorry, it was distance divided by speed. But here, it's grams, oh, it got moved on me. Grams per cubic centimeter. What do you measure in grams per cubic centimeter? They don't teach us anymore. Maybe in intro chemistry or something other, maybe. What is it? Yep. The meaning of the slope is the density. Grams per cubic centimeter. How dense it is. How heavy it is per its volume. Give me an example of something that's really dense. No names needed, by the way. Little joke there. What's something that's really dense? Diamonds, they're heavy, but based on their volume, right? What's an example gram of something that's not so dense? Okay. What about, yeah, it's not bad. I'm thinking something really light and fluffy. Cloud, maybe? Okay. Puff wheat cake, Rice Krispies, styrofoam is very undense, stuff like that. Sand. Okay. Good one. In question number 2 and question number 3, I'm expanding what you need to do here now. So now you actually have to plot the data. I did that for you in step 1. Question number 2, you have to plot the data. Then you have to draw the curve or line that best fits all points. Find the units of the slope. What's the name given to this quantity? It's an easy one. Find the value of the slope. Write an equation. And I'll answer the question, why isn't the y-intercept equal to 0? Use the new sheet now. I made a few changes, but I think it's going to make it better. I'm going to make a deal with you. You do number 2. I'm going to give you about 8 minutes or so. Then I'm going to give you the answers. Then we're going to try number 3. I will help you with question 2 here, and then maybe question 3 will be a little easier. Unfortunately, can I get it all on here? Yes, I can. Okay, let me get rid of all this junk here. All right, plot the values given in the table and draw the curve or line that best fits all points. Describe the resulting curve. Is it a line or a curve? Find the units of the slope of the graph. What is the name given to this quantity? So the first thing you do is graph x and y, right? So volume is down here. I'm going to write over here to the side. And this is going to be mass. Pretty straightforward. Put 0 on there, 10, 20, 30, 40, 50. I couldn't have made it much easier. Thank you. I guess I closed it. Oh yeah, I'm back. Okay, so let's graph here. You guys know the, you know what those are on the side there. So it's 10, 20, 30, 40, and 50. And up the side here, what'd you go by? 5s? 5, 10, 15, 20, 25, 30, 35, and 40. So 10 and 11 is going to be like about there. 20 and 18.9, roughly there. 30 and 26.8, roughly there. 40 and 34.7. And the last one is at 42.7, somewhere about there, right? Is this a linear relationship? Yes. Is it a perfect 100% straight line? No, it's not. And I can't even draw a very good line. But it's almost perfect, isn't it? Right? Like I didn't change them up too much, right? So yes, it is a line. I guess that's your answer for A. Find the units of the slope. Again, it's grams per cubic centimeter. I made it easy. What's the name given to this? This is the density. The slope of the line in every scientific application always means something. It may not mean something easily understood, but it will always mean something. What is the value of the slope of your line of best fit? Now, I had a discussion back there with Kieran. Your slope might be slightly different than mine. Is that okay? Yeah, because especially like in a graph like this where it's almost perfect, your slope's going to be almost exactly the same, right? But if it's one like the ones I showed you yesterday with the grades, you could have picked any 2 points you wanted, right? On purpose, I am not going to pick the endpoints because I want you to realize that you don't have to pick the endpoints. Okay? You have to pick 2 points because does it go through 0? It does not. So I'm going to use these 2 points here. So this one had a y value of 34.7. And this one has a y value of 11. And this one has an x value of 40, and this one has an x value of 10. Does everyone know where those numbers come from? Okay, so now it's just a matter of doing the subtraction and the actual math. If you don't know where those points come from, please ask. I get 23.7, and it's going to be over 30, and you get a slope of about 0.79 grams per cubic centimeter. Units are important. Jake, would you like 100,000? Exactly, 100,000 bucks or 100,000 smacks to the head. Units are important. Well done, Jake. Did we plan that ahead, or did you just know to say what? You just knew, yeah. What? Write an equation relating the volume to the mass of the alcohol. How do you write an equation? Remember, the general form of equation is y equals mx plus b. Remember that from about, what is that, grade 10 math? Grade 9? I don't know. So y equals, the m is this new slope I've got, 0.79x. What's the b value? Well, it's this point here, right? Could you actually solve for it? Yes, and a pure mathematician would make you, and I probably should too, but in the interest of time and not confusing too many people, I'm going to say let's just estimate the line, the slope, the y-intercept, okay? So I didn't draw a very good line here, but it looks like it's going to be about what? About 5? Did everyone just go through about 5, roughly? Okay. 3? Okay. If you're interested in knowing how that's actually done proper, then I will show you. Okay, but for now I'm going to allow you just to estimate. You would actually take the x value of 40 and you'd plug it in for x, and you'd take the y value here and you plug it in for y, and then you would solve for b, and that would give it to you, right? I see a few nods here. Good. Why isn't the y-intercept y equal to 0? What's causing the y-intercept to not be 0? Because if you have 0 cubic centimeters, shouldn't you have 0 grams? It should be 0, should it not? Sometimes when you weigh things, you got to put them in containers. So generally, that's going to be the mass of the container. Mass of the container equals approximately 5 grams. Most scientists will do what? They'll fix their balance. They'll set it up so that the container is already zeroed out, right? They'll put the container on. They'll press the tare button. It clears it to 0, and then that does the subtraction for you. Okay? But I wanted you to be aware of that. Do you think that will help you with question number 3? Okay. Question number 3 is almost the same. A slight increase in difficulty. I can see an improvement from number 2 here. So during the demonstration, the instructor placed a 1 kilogram mass on a horizontal table that was nearly frictionless. The instructor then applied various horizontal forces to the mass and measured the rate at which the mass gained speed or was accelerated for each force applied. The results of the experiment are shown on the table. Which one did he manipulate? Which one did he change? He changed the force and then he measured the acceleration. So that's why the force is the x and the acceleration is the y, okay? Plot the values given to the table and draw the curve or line that best fits all points. Oh yes, and I can see here that it will be, oh yeah, I got to do this, don't I? Okay. So here we're going to have force. Here we're going to have acceleration, and it's practically going to be like this, isn't it, right? I really should change those numbers a little bit, right? It's almost practically right on the... Does anyone know what those points are called? Like right on the grid points? You could call them a grid point. The correct term is a lattice point. Anybody got lattice in their backyard? You know, that sort of XY stuff? It's called lattice points. You don't need to know that. Anyways, you draw your straight line like that, right? It goes through 0, right? Pick any 2 points. What'd you get for a slope? 1, because it's practically, it's like 4.9 over 5 and 9.8 over 10. The slope is 1. What are the units of the slope? Acceleration is meters per second squared and force is in newtons, right? So your units for your slope are meters per, did I do this right? Meters per second squared per newton. Is that what you got? Yeah, am I right? I'm a little confused here. I think that's right. Does that mean anything to you? Not likely. A newton, 1 newton is a kilogram meter per second squared, which will cancel out nicely. Do you guys know the formula? F equals ma? Come on, you know this one. Yeah, and I know you paid attention to that diagram. I made a note of it because it didn't happen very often.
That's all I gotta agree.
I'm teasing you, Graham. Okay, but if I've got acceleration over force, right? How can I convert this to acceleration over force? Like if I divide both sides by m, I get a, right? And then I get f over m, but I don't want f over m, I want a over f, right? So then I got to take the f down here, and the acceleration is, and I know I'm confusing lots of you. The acceleration is actually equal to, I'm sorry, not the acceleration. If I go a over f, that's going to be equal to 1 over m. If you cancel these units down, you're going to get nothing over m. Does the slope have any meaning here? No. The slope has no meaning to either grade 11 students or even scientists.
No.
We had to do it that way because we adjusted the force and we measured the acceleration. If I had it the other way around, if I graphed acceleration down here and the force here, well then I would have newtons per meter per second squared, and then you'd have kilogram meters per second squared all over meters per second squared, and all that would cancel, and your unit would be kilograms, and it would be the mass of the object. And that would make sense. And I'm extending here, okay? If you don't get what I'm talking about, that's fine.
Doing it that way is right then.
It's what I'm saying is that sometimes for the slope to make sense, you have to flip the x and the y. Okay? That's what I'm trying to get at here.
That's originally I put
Yeah. Sometimes you just have to do it. That rule about the independent always goes on the x isn't always true. You can sort of fudge it a little bit if you have to. Okay, good. I think did you guys get something out of all that?
Yeah.
More or less? Should have got something. At the very least, you have to be able to calculate slope and give me the units for the slope. And you should be able to tell me what the meaning of the slope is. Those are the 3 things you got to get out of that. Okay. Now, do you want to stand up and come get some, or do you want me to hand them out to you? Some people like to go for a walk. You know? Okay, I would like you to do all of what we just did on a laptop. So you're going to have to get up and get a laptop. So get a laptop. There's probably not enough for everyone. I would say 1 per table. Those of you that are at a single table, you can get 1 for yourself. And also get 1 of these. There's 2 sheets. I think there's only enough of these ones for both. Yeah, take 1 of those and I'll hang up those. Grab 1 sheet.